Now just again I brief what we did in the previous classes because these things are required to understand further. You already studied the absolute stiffness and relative stiffness. For the member whose farther end is fixed, the absolute stiffness is 4 EI by L, whereas the relative stiffness is I by L. Similarly, the member whose farther end is hinged, the absolute stiffness is 3 I by L, and the relative stiffness is 3/4 of I by L. You know that distribution factor is equals to K by sigma K, where K is the relative stiffness, sigma K is the sum of the relative stiffness of the members meeting at the particular joint. You know that carryover factor is 1 by 2, that is 0.5. Carryover moment is 1/2 of the applied moment, and the carryover moment direction is same as that of the applied moment. Means if it is clockwise, carryover moment is also clockwise. If the applied moment is anti-clockwise, carryover moment is also anti-clockwise. Now we'll take the second problem. So in the first problem, A and C were fixed. Now I change the end condition. The A is fixed, B is a continuous, whereas C is the extreme end. Here A and C are called extreme ends. All other intermediates. All intermediates are taken as rigid. Of course, all joints are rigid, but they will be taken as fixed also. Now, if you look at this beam, AB has 6 meter, the I is 3I, whereas BC is also 6 meter, I is 2I. So these are the loads carried by the spans AB and BC. So as a boundary conditions, what should be the final moment at C? You know that MBA plus MBC equals 0. Similarly, what should be the final moment at C? Anybody? Hello? Hello? Yes, anybody can speak now. What is the final moment at C? Hello?
MCB equal to 0.
MCB equals to 0. So that is important to understand now. Whereas previous problem A was fixed, C was fixed, therefore MCB was also there, MAB was also there. Now look at this. First, as usual, you need to calculate fixed end moments. For span AB, it is MFAB is minus WL square by 12. And if you substitute the values of W and L, you are going to get minus 90. Similarly, MFBA is plus 90. I'm not going to tell detail about these already because you are already used it several times, even in slope deflection as well as moment distribution method, the formulas for fixed end moments. Okay. Next, for span CB, it is eccentrically loaded. So the MFBC is minus WAB square by L square. Substituting the value of 70, A is 4, B is 2, total is 6. So you'll get minus 32. And MFCB is plus, it is W. First one is WAB square by, it is A square B by L square or BA square by L square. So you'll get here plus 64 kilonewton meter. This is the first step. Second step is to calculate the distribution factors. See here again, you have to note down here important. First, as usual, 5 columns. First column is joints. Second is members. Third is K, that is nothing but relative stiffness. It is sigma K, relative stiffness of the joint, and distribution factor, which is equals to K by sigma K. This much you know. Now, as you know, the distribution factors will come for only intermediate joints. Okay, extreme ends will be only one member is coming from, for example, A joint, only one member is AB. So there is no need to distribute, that total moment goes to itself. Similarly for C, no question of distribution. When distribution comes means where the joint means, sorry, at the joint where the members are 2 or more than 2. Okay, means now for which joint you need to find the distribution factors? B. The members coming from B are BA and BC. Okay. So if you take joint as B and if you take member as BA, what is the far end for end condition for the member BA? Fixed. What is K for BA? Quickly answer me.
I by L.
I by L. Very good. I by L, but I is 3I, L is 6. So if you simplify that, you are going to get 0.5. Similarly now, if you write now BC, what is the end condition for the C, BC now? C is, what is the far end condition? BC member, B is near end, C is far end. What is the far end condition? Hinged,
3i by
roller
4L.
or simply supported, both are all are same. It may be hinged, roller or simply supported. Then what is K for such beam?
3i by 4L.
3/4 of I by L. We'll be calling like that. Okay, 3I by 4L is fine. It is 3/4 of I by L. Now 3/4 as it is, I is for span BC it is 2I. Again L is 6. If you simplify that, it will be 0.25I. Now for BA it is 0.5I. For BC it is 0.25I. Then what is sigma K? Quickly. 0.75 by I. Then what is distribution factor for BA? K of BA divided by sigma K. What is sigma K of BA? 0.5 divided by 0.75. It comes 0.67. Please keep your calculator with you and go on calculating so that you can better understand the things. Because don't see like a picture. Just 0.5 by 0.75, it is 0.67. Similarly, what is for BC distribution factor? K of BC divided by sigma K. What it should be?
0.33.
Okay, that is 0.33. It is 0.5 by 0.755 I is 0.67. 0.25 I divided by 0.75 I will be 0.33. Okay, here what is observed is only extreme end. If extreme end is fixed, the K is I by L. If the extreme end is simply supported, roller or hinged, it will be 3/4 of I by L. This is to be borne in mind. And this one earlier BC was also fixed, so there also we have taken just I by L only. But this is a different thing you need to observe. Now we'll see the moment distribution table. As usual, first column joint members, distribution factor, fixed and modes. These first you have to write. Joint members, distribution factor, fixed and modes. Okay. Next, joint means you start from the left hand, go towards the right hand. First joint is what? A. How many members are starting from A? Yes. How many members are starting from A?
1.
1. That is AB. Good. Now next joint is B. How many members are starting from B?
2.
2. What are those?
BA and BC.
D and BC. Fine. And the last joint is C, and only from that is CB. Okay. Now enter the distribution factors of the members. Now distribution factor is only for BA and BC, which you already calculated. BA has 0.67 and BC has 0.33. Now enter the fixed end moments for all the 4 ends. What is MFAB? Minus 90. MFBA will be plus 90. MFBC will be minus 32. MFCB will be plus 64. This much you have done it. Okay. First you enter the joints and corresponding members. Next enter the distribution factors. Next fixed end moments. Okay. Now in the previous problem, after this we started directly balancing and carry over. But here, as one of the extreme end is simply supported, you know that moment at that end is 0, right? Simply supported roller or hinged. Which is that end? Which is that end? C, isn't it? C. So you know that MCB is 0. So what you need to do here is, first let us make that moment as 0 at C, right? For that we initiate, instead of directly balancing, first we'll make the moment MCB as 0. How to make MCB 0? Can anybody tell me now? It is already plus 64 is there. How to make it 0? Yes.
Minus 64 at
Yes.
C.
Yes, you have to apply moment minus 64 at C. Then you have to carry over to the other end. For a member BC, if you apply moment at C, it should be carried over to which end? B. You are applying moment at C now, it should be carried over to B. If you apply at B, it should go to C. Okay. That step we call it as a release C and carry over. Releasing means what you are making, you know already end condition MCB is 0. So for that you are releasing it, means you are making it 0. To make 0, what I said, you have to apply minus 64. Now for a member BC, you applied minus 64 at C. Now it should be carried over to which end? D. That is BC. How it will be carried over? How much carried over moment?
plus 64.
Minus 64 is applied moment. What is carryover moment? Carryover moment equals to what? 1 by 2 into applied moment. So what is carryover moment then?
Minus 32.
Minus 32, very good. See now, this minus 64, it should be carried over to BC, half of that is minus 32. Is it clear? So first, you know that this step we have not done in the previous case because C was also fixed and A was also fixed. So there were no moments 0. But here, C is simply supported, maybe a roller, a hinge. So you know that there the moment is 0. So you make it 0. To make it 0, you have to apply the opposite moment of or minus the moment which is already existing at CB. Then once if you apply that moment, it should be carried over to the far end. Okay, this step is clear. Now what you do is you take the initial moments. Now your moment distribution starts from this step. Initial moments means you add now this 90, it will come here. Similarly, this plus 90 will come over here. Now this minus 32 minus 38, how much it becomes? Minus 64. Whereas last column becomes 0. Plus 64 minus 64 becomes 0. Now these will become initial moments. Now onwards, whenever you add total moments, you have to take these as the first step moments. Is it clear? In the previous case, from here directly I have started balancing and carryover because there was no need to release any end because they were fixed. But now in this case, end C is simply supported. So hence you know that moment at that end is 0. So you make that 0. How to make 0? You have to apply opposite moment, then carry over to the far end. This is what we are doing. Once if you do this, you take as a initial steps. Okay. This is the additional step what you are doing whenever any extreme end comes as simply supported. Now as usual, further step is balancing and carryover. Now which joint you need to balance? Which joint you need to balance? Hello. Hello. B. Always intermediate joints because MBA plus MBC equals to 0. You know that. If it is not there, it is unbalanced. Now, what is the unbalanced moment here at B? Plus 90.
26.
Plus 90 minus 64 is the unbalanced moment. That is plus 36. Okay. Sorry, 26 I think. Is it 26 or 36?
26, sir.
26. Therefore, what is balancing moment then? What is balancing moment?
26.
Minus 26. See, these you need not to show in the calculation. Directly we can do it. But for the first two problems, just I am giving you the steps. So, unbalanced moment is the sum of BA and BC. Plus 90 minus 64. So, it will become plus 26. So, it is unbalanced. So, you need to balance it by applying a minus of unbalanced moment. So, it will become minus 26. Then minus 26 moment for joint B is to be distributed among BA and BC because there are two members emerging from BA and BC. Then how do you get the moment of BA now? That balancing moment multiplied by distribution factor means minus 26 into 0.67. What is that? It is called MBA, balancing moment minus distribution factor of BA, minus 26 into 0.67. How much it comes? Minus 17.42. Similarly, MBC will be balancing moment into distribution factor of BC. So it is minus 8.5. Now, therefore, you write here. Moment under BA is minus 17.42. Then moment under BC is minus 8.58. Okay. After this, what you have to do now? Carry over. Right? Which moment will be carried over? Can anybody tell me? Which moment will be carried over and to which end? Quickly.
B will be carried over to A and C.
No. BA will be carried over to AB. That is first thing. Because that end A is fixed. Is it correct? BA moment will be carried over to AB. How much? How much? Yes, 1 by 2 into MBA. That means MAB equals to 1 by 2 into MBA. That is minus 8.71. Okay. Now let us see that. minus 17.4, it will be carried over to this one. It is that minus 17.42 divided by 2, you have to do. It comes minus 8.71. Is it correct? Is it correct or not? Hello? Hello? Then next
Yes, sir.
question, is the amount BC carried over to which end? Now BC should be carried over to
CB.
CB. No, here it will not carry over because it is simply supported. Only if the end is continuous or if the end is fixed, then the moment will be carried over. If the far end is hinged, no moment will be carried over. I think in the initial stages I have told that. Only if the far end is fixed, the moment will be carried over by half the magnitude. If the far end is hinged, no moment will be carried over. Whereas earlier we carried over because C was fixed. Is it clear? This is the difference between when the far end is simply supported and are fixed. Is it clear? Only now BA will be carried over to AB, but BC actually if C is fixed, this would have come here minus that is 4 point something. But now as the C is released already, once if you release means no contributing towards that end and no distributing to that end, no carrying over to that end, means that steps here over, because here if you get some values under BA and BC, then it becomes unbalanced, then you need to balance, but no moments have come after carried over, so the step ends here. Now you have to take the final moments. From where you have to join add now final moments? Is it from fixed end moment or from initial moments? You have to add all the moments in that column. From where you should start? Hello?
Initial moments.
Initial moments. Because once if you release, always initial moments will become the first step. So from this you have to add this. Minus 90 minus 8.71. How much?
98.71.
Very good. Next tell me, plus 90 minus 17.42.
Plus 72.58.
Yes. Next, minus 64 minus 8.58.
Minus 72.58.
Minus 72.5. Last one. 0. Is it clear? So once again I repeat, if the far end is hinged or simply supported roller, first you need to release it. How to release that? You have to apply opposite moment to the existing moment. Then it should be carried over to the other end. Then you take the sum of the moments and call them as initial moments. Then start balancing and carry over. So balancing means intermediate joints have to be balanced. First you have to calculate unbalanced moment, adding MBA and MBC. Then balancing moment will be minus of the unbalanced moment. That unbalanced moment, balancing moment into distribution factor of each member gives the moment to those ends. Then carry over. If the far end is fixed, it will be carried over by half the magnitude. If the BC is there moment, you apply that moment, but it should be carried over to CB. But as C is hinged, no moment will be carried over to CB. So then you are not getting any moments here. So this will become unbalanced. That is no question of balancing. Then directly take the sum of the end moments from initial moments and complete the problem. I hope it is clear. Yes. Now calculation. Now drawing the bending moment diagram will be same. So I applied the moments. You look at this. Calculate the UDL means WL square by 8. Span BC is carrying point load not at the center. Hence it is WAB by L. So you have to complete the bending moment diagram like this. I think is it necessary to again repeat how to draw the bending moment diagram? Hello? Anybody? Hello? Hello? Can you speak? Hello? Hello? Are you listening? Hello? 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 Anybody is Can you hear me? Okay.
Clear, sir.
Please tell me something, otherwise I cannot understand what you are. Okay, next is shear force diagram. As you know that again you have to apply moments as usual and apply loading also. Calculate this, for example, I will repeat this. If for this span AB, so if you take moment about B, RA into 6, it is clockwise. This is anti-clockwise, so minus 98.71. The moment due to 30 kilonewton per meter is also anti-clockwise. 30 into 6 into 6 by 2 minus. Then this moment is clockwise, so plus 72.58 equated to 0, you will get RA. Then write down sigma Fy equals 0. This RA plus RB1 equals to total downward load. What is total downward load? 30 into 6 minus, or if you bring this side, it will become plus. Then RB1 equals to this 30 into 6, that is 180 minus 94.36 will come here 85.64. Similarly, for this span, if you take moment about C, RB into 6 minus 72.58 minus 70 into 2 equals to 0, because this end moment is 0. So you will get RB2. If you write sigma Fy, RB2 plus RC minus 70 equals to 0. Substitute the value of RB2 here, you will get RC 34.57. So once if you get the final moments here, reactions, it will be like this. You calculate, this is up, so 94.36 will be up. Then 94.36 here, just to the left of the B, this much load. This, what is that load? 94.36 is plus minus 30 into 6. How much it comes? Go on calculating. 94.36 minus 30 into 6. How much it will be? Quickly you have to tell. I said keep the calculator ready with you. What is the value? 94.36 minus 30 into 6. Hello?
Minus
Yes,
85.
minus 85 meant below the baseline, it is minus 89 this point. Then if you cross the B, to the left of the B, minus 85.64, then there is a at B plus 85.64 up. So it goes to 0. Minus 85.64 plus 85.64, it goes to 0. Here moments will not come, because shear force means only vertical loads will come into picture here. Similarly for this beam, here RB2, that is 35.43 up. And here to here there is no load, so it remains constant. Whereas here the load goes on decreasing, therefore this line goes on decreasing. Then to the left of this point, it is 35.43. To the right means 35.43 minus 70. How much it comes? 35
34.57.
minus 34.57. So from the baseline, it is minus 34. So from here to here, if you think, it will be 70. From here to here, 34.75. From base to up, 35.43. If you add those two, automatically you will get this 70 kilonewton. You can check this. This plus this value. This is plus, this is minus. But total value is, absolute value is 70. Then again, from here to here, there is no load. So this will remain constant. To the left of the C, it is minus 34.57. If you cross the point, what happens? Minus 34.57 plus, because upward 34.57, it goes to 0. Right? Or you can just add these two, it will be like this. Okay, I think it is clear, because you already learned about shear forces in the which semester? Third semester. Or is this clear? If you have doubts, no problem, you can ask me. Is this clear how to draw the SFD? Shear force diagram? Hello?
Yes, sir.
This is the final thing. Need shear force diagram is also completed. Now I'll quickly go through the one more problem, which is having 3 spans. Look at this. Analyze the continuous beam shown in figure by moment distribution method and draw BM and SF diagram. Also draw the elastic curve. Elastic curve is a deflected shape. Okay. Okay. What is the first step? Fixed end moments. I will quickly go through this. MFAB minus WL square by 12. So we'll get minus 20.83. MFBA will be plus WA square by 12. We'll get plus 20.83. MFBC is minus WAB square by L square. So after substituting A and B, you will get minus 4.69. MFCB is WA square B by L square. So substituting the value, you will get plus 14.06. And last one you can see now, total span he has given 5, 1 and 2.5 means it is at the center. If it is at the center, it is minus WL by 8. Otherwise, even you can remember this AB square and BA square. A equals to 2.5, B equals to 2.5. Even if you substitute, you will get the same answer. Okay. MFCD, it is minus 25. MFDC will become plus 25. I think you do not have any problems in calculation of fixed end moments. Okay. Now I'll go to the next step, that is distribution factors. Now, again, first as usual, joint members K, relative stiffness sigma K, distribution factor, that is K by sigma P. Now, earlier I have taken two span continuous beam, so only one was the intermediate joint. Now, how many intermediate joints are here? Two. So it means for both joints you need to calculate distribution factors. First, let me take the joint B. What are the members starting from joint B now?
BA and BC.
Yes, BA and BC. You have to complete first. Let me complete first joint B. What is the K of BA?
I by L.
I by L. That is I by 5. So you will get 0.2 I. Now, what is the K of BC?
I by L.
Yes, it is I by L only. Though C is marked like simply supported, but intermediate joint it is. Intermediate joints are all taken as fixed. Only if extreme end is simply supported, then it should be taken as a 3/4. Otherwise, all will be I by L only. Is this clear? Though C is marked like simply supported, it is not an extreme end. This will be extreme end. So all intermediate supports are taken as fixed only. So that is also I by L. But what is I? 2I, L is 4. So it is 0.5 I. Then what is sigma K? Quickly do it.
0.7 I.
0.7 I, very good. Then what is distribution factor of BA? 0.2 I divided by 0.7 I. Do it.
0.28. 0.28.
Say 0.29 I will take. I think third digit is more than 3. If you have 5, you can add 1. Okay. Similarly, for another one, for BC will be 0.5 I divided by 0.75. I think it is 0.71. Yes, are you getting the same thing?
Yes, sir.
Okay. Now let me take another joint C. Now what are the members from C now?
CB and CD.
CB and CD. Fine. What is CB? IK.
I by L.
I by L. But I is 2I, L is 4. So you have to be very careful about whether it is I by L or 3/4 I by L. First thing. Second thing is what is the I of the respective span. You have to be very careful about this. Now I is 2I, L is 4. Again it is 0.5 I. What about CD?
I by L.
I by L, very good. I is I only, I by I is 5, it is 0.25. I think again it comes 0.7, so it will become 0.71 and this will become 0.29. Check it if you want. 0.5 by 0.7, you will get 0.71. 0.2 I by 0.7 I, you will get 0.29. I think you understood now how to calculate distribution factors for the intermediate joints. If only one intermediate joint is there, you will get only one row. Means in that you will get two members, of course. As there are two intermediate joints, so you will get for both the joints, each joint has got two members. So you need to calculate distribution factors like this. Is this clear? Hello? Hello?
Yes, sir.
So now I will not show any calculation. Directly I will do with the table. Be ready with your calculator. You go on telling me, I will write the values. I don't solve this. But here you will get 3-4 cycles. Previously we have completed the problem in 1 cycle, because after carrying over there were no moments at the intermediate joints. So therefore that balancing question doesn't come. But whereas here you will get it. Are you ready now with calculator? Say yes or no quickly.
Yes, sir.
Sir.
Okay, now we'll go with moment distribution. Okay, now Salpa, be careful now. You try to understand. This is the problem where you means you will get the perfect. First, you write the first column 4 heads. One is joint, second is members, third is distribution, fourth is fixed elements. This much you have to enter. Okay, you know there are 4 joints. Am I right? Quickly you have to interact with me. First joint is
A.
Members coming from A is
AB.
AB. Good. So all of you listen me attentively. Be attentive for a 15 minutes. This is a crucial problem where you will become perfect. Next, joint B. How many members?
2 members.
BA and BC. Fine. Next joint C. How many members?
2.
Which are those?
CBCD.
Very good. Last joint
Once. DC.
DC. Fine. Enter the distribution factors of BA, BC, CB, CD, because only for intermediate joints I have told, only for the members of the intermediate joints. Okay. AB will not come. BA 0.29 you have calculated. BC 0.71 you have calculated. CB 0.71. CD 0.29. Again, DC is only one member. There is no distribution factor. Enter the fixed end moments. MFAB minus 20.83. Correct? MFBA plus 20.83. MFBC minus 4.69. MFCB plus 14.06. It is minus 25 plus 20. I think you don't have any problem in writing these. Just you are writing these from the previous 2 steps. Is it clear? Any question here writing these problem? First 4 rows. Yes. Is there any difficulty in writing these?
No, sir.
No. Okay. Now, whether now balancing carryover starts or releasing end starts. When the releasing comes,
For hinge and simply support.
if extreme ends, if either A or D, if any one of them is hinged or simply supported roller, then it is to be released. Not about intermediate. Now, what are the end conditions of A and D? Yes. What are the end conditions of the A and D?
Fixed.
Fixed. So no need to release them. Then directly what it starts now? Balancing and carry. Okay. Now balancing you should start from intermediate joints. There are 2 joints now, B and C. First let me balance B joint. At joint B, MBA plus MBC should be 0. You add them, is it 0? No, isn't it? No, plus 20.83 minus 4.69. How much?
16.1.
You do it with me. You do it with me now because I'm not showing the calculations right now. Okay. Plus 20.83 minus 4.69. How much? How much?
16.14. Plus 16.14.
0.14.
That is unbalanced moment. What is the balancing moment then?
Minus
Minus
16.14.
16.14. No. Unbalanced moment is plus, isn't it? So balancing moment will be minus. Plus 20.83 minus 4.69. It is plus. Am I right? That is unbalanced moment.
Yes, sir.
So balancing moment will be minus of that. Minus of plus means minus. Now, that balancing moment multiplied by distribution factor of BA, how much? 0.29. That's 16 point whatever you are getting, keep it in memory first. Once you multiply by 0.29, then that will be coming over here. How much?
Minus 4.68.
6806.
Yes, very good. Then under BC now, that balancing moment multiplied by distribution factor of BC, that is 0.71. Tell me how much it comes. That's why I said that balancing moment, keep it in memory. So that once multiplied by 29, that next multiplied by 0.71, it comes under BC. Yes, how much?
Minus 11.65.
Minus 11, how much? Check it. Check it. Is it correct? 11.46?
11.46, sir.
Then it is right.
Minus
What I have done.
11.4.
Yes, is this clear now? I am not sure. You need not, even in exam or test, you need not to show the calculations there. You should go on doing like this only. Just for your reference, in the first two steps, I have given you what is unbalanced moment, what is balancing moment, then how to distribute that, those things I have told. I think this much is clear, everybody. What do you have to do now? BA, BC you have to add, right? Change the sign, that will become balancing moment. That balancing moment multiplied by the distribution of factor BA, it will come over here. The same balancing moment multiplied by distribution factor of BC comes over here. Are you getting these two? Yes. Hello.
Sir.
Hello.
Yes, sir.
I am asking same voices, no other voices. Very 2-3 typical voices I am listening. I am very happy about them. But what about others? I don't know. Some, I think some students I know, they keep on and go somewhere else. Because once I close that meeting session, I will find some of them will be there on the still. See, I don't know why just some of them never attend the class, but on test day they will be very punctual, getting copied from some and submitting the things. See, here it is your responsibility. See, what is sincerity or honesty? When there is no supervision, if you are doing, that is the honesty. See, by cheating here you can pass, but in life you cannot pass like this. And for basic civil engineers, this structure is a very important thing. Okay, now let me come to joint C. Now joint C means there is members are CB and CD. What is the unbalanced moment? Plus 14.06 minus
10.94.
Minus 10 point something. That is the 94, isn't it? Then what is the balancing moment?
Plus 10.94.
Plus 10.94. Very good. Then how do you get the value here now? That's
7.76.
10 point something into 0.71 you do it.
7.76.
Okay. Plus that is a plus 0.76 something, you will get say 7.77. Okay. Similarly under the CD, how much you will get? That balancing
Minus
amount multiplied
3.17.
3.17. Fine. Very good. Then BC, no question of balancing. Similarly, AB, no question of balancing. Balancing comes only for intermediate joints. You remember this. Now next step is what? Once if you balance, next step is
Carry over.
carry over. So now this value BA, where it should be carried over?
AB.
Interchange the letters BA, AB. It should go to AB. How much? Half of that. What is half of that? Minus 2.34. Am I right? See now, this will be carried over to BA. It will be minus 2.34. Is it correct? Yes.
Yes, sir.
Okay.
Yes,
Okay,
sir.
very good. Then BC, this value, where it should go?
CB.
CB. Good. How much? Minus 11.46 divided by 2 you do. Or 0.5 multiply.
5.7. Minus 5.73.
Minus 5.73. Good. Now this value is over, this value is over. Now you come to this CB, where it should go.
BC.
BC, very good. BC, how much? Point multiply by 0.5.
3.88.
Sign
Positive.
plus only. If it is plus, plus. If it is minus, minus. See, minus 11.46, so carried over moment is also minus. So this is plus, this is plus. Next, these three moments we have carried over. What about 3.17 now? Where it should go?
BC.
DC.
BC, very nice. How much?
1.585.
1.585, fantastic. It will be like a game. You are playing a game on computer, similarly with calculator. I think the first step is clear.
Yes, sir.
Now you are iterating the cycles. 3-4 cycles you have to do till carryover moments are in the very small amount, like 0.0 something like that. Okay, is this step clear?
Yes, sir.
Now I'll go with the next step. Next step is again balancing and carryover. Okay, because now if you take joint B now, here there is no moment has come, but here moment has come. The sum of these two should be 0. Whether the value comes here after carryover or comes here, it makes it unbalanced, isn't it? Then if you take joint B, what is the unbalanced moment? This plus this. If this is not there, you assume it as 0. What is the unbalanced moment?
Minus 3.
Minus 3.885.
Listen me carefully. I am asking you unbalanced moment. It is, you are one step ahead of me. Okay. It is unbalanced moment is 3.885 plus 0, that is plus 3.885 is unbalanced moment. So what is the balancing moment?
Minus 3.885.
Very good. Now, then what is the contribution for BA? How it comes now? Balancing moment multiplied by distribution factor of BA. That means minus 3.885 into 0.29. How much it comes?
Minus 1.13.
Minus
Minus 1.12.
127. Okay, I think same. One digit variation, fine. But you are getting this much, isn't it? Next, what is the moment under BC? What is the moment under BC? It is that unbalanced balancing moment multiplied by distribution factor of BC. Distribution factor of BC is 0.71. What is that value?
Minus 2.79.
0.76.
Okay. No problem. My 2.76 or 2.758. No problem. Even if you write 76, nothing wrong in that. Okay, is this clear now? Balancing B is over now. Similarly, come to joint C. Balance it. The C means there are two members, CB, CD, but here no moment has come. But still, if you add these two, if it is not coming 0, it is unbalanced only. What is the unbalanced moment at C now?
Minus 5.73.
Minus 5.73 is the unbalanced moment. So what is the balancing moment?
Plus 5.
Plus 5.73. Very good. Then how do you get the contributions of CB and CD? Balancing moment multiplied by the distribution factor of each member. That means
4.06.
5.73 into 0.71. You will get
4.06.
Okay. Okay. Then similarly under CD, it is balancing moment multiplied by 0.29.
1.66.
1.66.
1.66. Very good. Now this is over. Balancing is over because there are only two intermediate joints. Balancing goes. Next, carryover. Isn't it? Next step is carryover. See, first time if you make arrows from where to where it goes, it repeats for all the cycles. This value, where it should go now? BA2, where it should go?
AB.
AB, how much?
Minus 0.56.
Minus 0.564.
563.
Okay, no problem. You write it, nothing wrong in that. Next, this you carry. Next, this one, where it should go? BC to CB. Fantastic. How much? You have to divide by 2.
1.379.
Minus 1.379. Very good. Then This moment, 4.068 moment CB, where it should go?
BC.
BC. How much?
2.034.
Okay, fantastic. And the last moment, 1.662, where it should go?
BC.
BC. How much?
0.831.
0.831.
831. Is it correct?
Sir.
Now you repeat, third cycle you do it. I will wait for 1 minute. You keep ready your values. Balancing and carry over. At least these 2 cycles write in your notebook. And keep ready. Balancing. Next is again balancing and carry over. First you write that. First joint balance B. Next balance C. Then carry over. First you keep ready those values. It is a iterative. These are the iteration means some more cycles you need to do till you get a smaller value. I'll give you 1 minute time. Quickly do that.
Minus 0.589.
1 minute. I will give everybody. Let them do it. I will ask at that time. You can tell. Keep ready balancing as well as carry over moments. Yes, over.
Yes, sir.
Okay. Tell me what is the balancing moment under BA?
Minus 0.589.
Very good. BC?
Minus 1.44.
Very good. CB?
Plus 0.97.
Plus 0.7979. Very good. Under CD?
0.39.
0.399. Okay. Listen, may I tell you again here how these have come for those who are not understood. See, it is not the question of understanding. Just you should be attentive and you should practice. That is the only way. Even 10 problems if I solve, you will not understand. One problem is enough if you clearly do the things. Okay. See, these 2 columns, if you add, it will become 2.034. So this is 0. So it will be minus 2.034 will be the balancing moment. Minus 2.034 into 0.29, you will get this much. Minus 0.589. Minus 2.034 into 0.71, it comes minus 1.444. Isn't it? Next, this one, this plus this is minus 1.375, this is 0. So minus 1.379 will be the unbalanced moment. Balancing moment will be plus 1.379 into 0.71. You will get this. Plus 1.379 into 0.29. You will get this. Okay. Next, carry over is 50%. 0.58. How much?
Minus 0.29.
Very good. Then BC2 it goes to CB. How much?
Plus 0.489.
0.79.
Minus
0.72. 0.72. Minus.
Minus 0.72.
Minus 0.72.
Okay. Then 979, where it should go?
BC.
BC.
How much?
0.48.
0.48.
Very good. And last one, 0.399, where it should go?
BC.
BC.
Oh,
0.199. Yes.
9. Okay, can you do one more cycle now? Do this balancing and carry over. 2 more cycles you have to do. So that at least 5 cycles you do. So that now I think look at this cycle. Are you getting same values? What? Yes, is it correct?
Yes, sir.
Sir.
That 0.489 into 0.29 will get minus 0.489 into 0.71 will give this much. This is unbalanced amount is minus 0.722. So it will be balancing amount will be plus 0.722 into 0.7 will get this. 0.722 into 0.29, you will get this, then carrying over. Next, if you do one more cycle, so you will get here 0.257 plus. So it is an unbalanced amount. Balancing amount will be minus 0.257 into 0.29. You will get this. Is it correct?
Yes, sir.
Sir, 1 minute class में आया तुम. Yes, is it correct?
Yes, sir.
Yes, sir.
Next value BC.
Minus 0.182.
182 or 183, doesn't matter.
Yes, sir.
Similarly, tell me for CB and CD now. Minus 0.174 is the unbalanced amount. Balancing amount will be plus. Plus 0.174 into 0.71.
0.124.
0.123.
Okay, very good. Next, for CD,
Zero 0.050.
0.050 or 51.
Yes.
Okay. Next, carry over. See, last cycle, you want to carry over, if you want to end, you have to carry over to only extreme ends, not intermediate. So means extreme ends means BA to AB and CD to DC. Only this much you need to carry. Get the final moments. Start from the fixed end moments and add up all the moments in that column and write down all the moments. Let me see. Start MAB. Fixed end moments onwards, you should start. Add up all the moments in that column. So what is MAB?
Minus 24.
Minus 24.1.
Minus 24.138.
Fine, very good. Go ahead with next column. BA. On the screen it is there, you just add it.
13.917.
Check it.
Minus 3.493.
Check it.
40.217.
215 or 22, okay. You should start from fixed end moments. Don't add distribution factor. Starting from fixed end moment till last value in that column. Yes, how much? Is it 14.22?
Yes, sir.
What should be BC then? Should come minus 14.22 because MBA plus MB should be 0. That is the check it. MBC, you should start from fixed end moment, go on adding, see, check how much you are getting. Yes, anybody getting it? Yes.
Minus
Hello.
14.22.
Minus 14.22. Very good. Continue with CB, CD, DC. You have to add from fixed end moment onwards. If you are released, initial moment onwards. Those things you should take care. Yes, what is MCB?
18.406.
Check it once again.
19.509.
Okay, 19.509. Okay, 19.51 you can write. Then what should be CD? It should be minus 19.51. Check it.
19.5.
Check it, check it.
Minus 19.50.
Okay, very good. 19.50 if you get, nothing wrong in that. See, if you do, that is number of cycles. Okay. Suppose if you get 19.5, 19.4849, that means if you do one more cycle, you will get the precise value. That is the thing. If you usually in the exam, you bet maximum you can do 5 cycles. Last 5th cycle, you can stop. Last one, do it DC.
27.746.
7.746.
Okay, okay. 746, I have written 75. Any more times here post diagram, that is usual. Mark the end moments, draw the bending moment diagram, superimposed by free bending moment coordinate. I have given everything here. End moments with sign, free bending moment, its value for span AB, BC, I think it should be CD. This is AB, BC, this is for CD, WL by 4, CD last span. Okay, I think I need not to repeat again how to draw the bending moment diagram. Already I have explained for many problems. Is it okay?
Okay, sir.
Yes, sir.
Okay, very good. Next, shear force diagram. Now we have done for 2 spans. Now it will be for another span. Same thing you have to continue. Mark the end moments, mark the loading, calculate the reactions by writing equations of equilibrium. For example, one I will explain here. If you write sigma mb equals 0, it is Ra into 5 clockwise. This is anti-clockwise minus 24.138. This 10 kilowatt also makes anti-clockwise 10 into 5 into 5 by 2. This end moment is plus 14.22 equals to 0. You will get Ra. Then Ra plus Rb1 equals to minus this load. That is 10 into 5 equals to 0. You will get Ra. Similarly, for all 3 spans, you calculate the reactions in the similar way. I have shown here calculations, but you should try. Don't. If you listen the problem, you will never understand. You have to take it, you have to solve it. Suppose if you make mistake, you have to understand where is the mistake. Once if you get that point clear, you will never repeat the mistake. That should happen. Okay? Then you have to write the values, draw the shear force diagram. This 26.98 up. If you come to B end, 26.98 minus 10 into 550, you get minus 23.02. Up to left, minus 23. If you cross the B, minus 23 plus 23, it goes to 0. Next, this span, plus 4.93 here. B2, this load left, no loading, so it remains constant. So up to here, plus 4.93. If you cross the point, minus 25. So you will get this 20.07 you will get here. Then minus 20.07 plus 27.07, it goes to 0. Similarly with this span. Now I will show with suppose if you club the spans, what happens? Let me see here. RB1, RB2. If you add these two, it will become RB now, 27.95. RC1 and RC2, if you add, you will get net RC, 38.2. RA is single, RD is single. Now listen me here, how to draw this. This is the baseline you have to draw. Mark A, B, C, D on that. First at A, plus 26.98 up. Okay. Next at B left, how much it is? 26.98 minus 10 into 550. Do that, how much you get? See? Plus 26.98 minus 50.
Minus 23.
Minus 20.
Minus 20.
Minus 23.02, isn't it? Next, it is up to B left. If you cross the point, minus 23.02 plus is net 27 plus 27.95. Minus 23.02 plus this net value 27.95. How much will be? Yes, it will be plus 4.93 means about the baseline, it will become plus 4.9. And up to this load, there is no loading B to this load, it remains constant. Okay. Next, if you cross the load, this previous value plus 4.93 minus 25. How much it comes, sir? Plus 4.93 minus 20.27. Very good. Then up to from this point to C left, there is no load, it remains constant. Next, minus 20.27 plus this reaction, 38.42. How much? Minus
18.15.
18.35. Isn't it?
1.5.
1.5?
Plus 18.35.
35, that's what I'm asking. Plus 18.35 will get. Then up to this load, it remains constant. Next, if you cross this load, plus 18.35 minus 40.
Minus
Minus
21.65.
21.65.
Minus 21.65.
1.65.
Correct. Then from here to here, there is no loading, so it remains constant up to D left. Next, minus 21.65, there is a one upward load, plus 21.65, it goes to G. Is it clear?
Yes, sir.
This is if you combine the spans, this is the procedure, or previously what I have done, that is also fine. This is also fine. Anyone you can do it.